Morning. Last time we discussed the Laplace transform and the Laplace transform properties, especially the common Laplace transform pairs. Today we are going to discuss with the examples how to find the Laplace transform of signals. Before that, we want to emphasize the Laplace transform pairs. I ask you to review this, better to memorize some of them, the most important part. Okay, so let's see the first one. Delta t. What's the Laplace transform for this? 1. Okay, perfect. Understand the physical meaning for this? Why it is equals to 1? Sure, we can use the formula to calculate this, plug into this as xt, then we calculate, okay, it is equals to 1. For engineers, okay, technologists, how to understand this? Why the impulse function Laplace transform equals 1? How to understand it? Not only from the mathematics. This function is in time domain, right? How to generate this? The impulse, the amplitude equals infinity, but the duration in time is equal to 0. Can we generate this signal in labs? Theoretically, we can say, okay, you turn on, turn off, then that gives us spike, right? So, as you said, we cannot generate this in labs. Why we cannot generate this in labs?
Can't do it instantaneously.
Okay, we cannot do instantaneously in time. Right? That is how we understand this in time. You cannot do this in no time. Frequently, okay, in Laplace domain. That means this one must be a function of, we know xt, the Laplace transform gives xn, which is a function of s, right? And here, that is only a 1. So for this one equals 1. What does that mean? This one is not function of s. That means it's not function of time, frequency. That means no matter what the frequency is, the amplitude is always equal to 1. That means when the frequency equals 0, the amplitude equals 1, frequency equals 1 equals 1. And frequency equals 1 gig equals 1. 1,000 gigahertz still equals 1. Even when the frequency equals infinity, that still equals 1. That means this signal has the bandwidth equals infinite. Definitely, we cannot generate a signal with infinite bandwidth, so that's why we cannot do it. Right? The modern tech equipment can create a signal, this one, as narrow as, for example, nanosecond duration. This one has a very wide bandwidth, but still cannot equal infinity. Right? As far as I know, looks like, I don't know, we cannot generate this kind of signal in real life. That's possible. Second one, now we need to use the properties. I delay this impulse by t sub naught time. What is this? What's the Laplace transform for this one? This is ideal delay, right?
1 minus t0.
Okay, 1 minus t0. Right? Remember the property for Laplace transform. This one is only delayed by time. So the form is still to this function, right? So still equal to 1. You ignore this minus t0, so this impulse t still equals 1. Then it must be multiplied by exponential, which is negative t sub 0 times s, right? Right? So this one is not necessary to be here, so that's the result. Right? The next one is ut. Ut is integration of this delta t. The integration gives us a Laplace transform of the original Laplace transform divided by s. Right? So this one will give us a 1 over s. then t times ut, or we say rt. This one is the differentiation of this one. Right? Differentiation gives us a Laplace transform multiplied by s, right? Then minus the initial conditions, some terms related to the initial conditions. Right? If the signal initial conditions equals 0, then that just equals s times 1, then just equals s. Oh, sorry, no. RT is, what I said is wrong. RT is the integral of this one, right? So integral, that means we need to divide it by s again. So that's 1 over s squared. Then if we multiply this by n times ut, this one gives us n factorial, then s divided by s to the power of n to the s to the power of n plus 1. And ut minus t sub 0, this one is very typical. When we analyze the circuit like this, if we have some signals like this here, so we have a circuit on this point, we can close this switch at when t equals 0. Right? So that means this input will be equals just, for example, equals 1 volt, just equals ut. Or we can close this switch as t equals, for example, 10 seconds. Then this signal will be equals ut minus 10 seconds. So we have every reason to use this ut minus t sub 0. So in 412, we are going to use a lot of these kind of representations. So we need to know what is the Laplace transform to ut minus t sub 0. That's very similar to this one. So it is just the original Laplace transform then multiplied by e to the negative t sub 0 s. Ut give us s, 1 over s, 1 over s. Then multiply by this one, e to the negative t sub 0. We have another one, e to the at, negative at, and ut. This is the first example we discussed Laplace transform. We calculate this directly from the definition. Again, you need to memorize this. This is 1 over s plus a. Alright, the next one is cosine function, cosine omega t times ut. What is this? Last time I mentioned a trick I used to memorize this. Anyone? Alright, first one is on the bottom, that will be omega squared plus s squared. Usually we write s squared plus omega squared. On the top, s, because we don't have s here, right? So that's why we have s on the top. Not the direct reason, but how we memorize it. Then, for cosine function, omega t times ut, this one will be, the bottom will be the same. On the top, just constant omega. Again, in circuit analysis, most probably we are going to not only use these cosine or sine functions as the input. We are going to use a attenuated harmonic signal. So that means this one is e to the negative at, like this. How to calculate what is the Laplace transform of this one? We must, again, use the property. We multiply e to the negative at. We only replace in the Laplace transform, the original Laplace transform. We only replace the s with s plus a, right? So this one will be just the a here, and this s square will be s plus a square. So that's plus a square. Not plus a square at the back, right? Every s is replaced by s plus a. Same thing here, negative times e to the negative at, then we don't have any s on the top, so we are okay with that. On the bottom, this s will be changed to s plus a, then squared. Any questions on that? And we also have a linear property, all this. So today we are going to calculate some Laplace transform. As we said, I'm going to let you do it. So if you have a lecture notes open, please close or just get a piece of paper. We do the practice. The first one is example 1. Xt equals 5e to the negative 2t minus 3 times sine 4t. Cheat sheet is on the left. That is the common pairs. Use a linear property, right? The input signal has two terms, this and this. So the Laplace transform of this is the Laplace transform of this plus the Laplace transform of this. So you just break this one into two parts, then calculate the Laplace transform of each one, then add up together. That's it. And we have assumption here, everything only for t greater than 0. Right? That means we have a ut multiplied by this. We do not consider that sum. It's good? Okay? So the Laplace transform of this, as we said, we have two parts. Right? The first part. Anyone try? How about we in order? Right? You try the first part. Do we have any kind be used here? Which one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one do you want to use?
7.
7. Right? This one. So what is it?
1 over STA.
1
5.
over S.
There wouldn't be a.
Where's the unit step?
Huh?
Where's the unit step function?
What is the,
So where's the unit step function in there? Is that 7 has...
you mean the unit step?
Yeah.
Unit step of S is here. Means for all, only t greater than 0. So that is something like multiplied by ut, right? Because this one is defined on all time, but the ut only defined by positive time, including 0. So this one means if you don't like this ut, you just write t greater than 0, or greater or equal to 0. So that's it. You can write everything here, then times ut, or you can just write t greater than 0. That's the same thing, right? Alright, so 1 over S.
So it would be 2t.
T. Alright, in the Laplace transform, there's no time. It's only frequency, there's no t. I did see some from previous experience. Somebody in the Laplace transform has a lot of t's. That is definitely not correct. No t. T is in time. We only have a function of s. e to the negative at. What is the a here?
A is 2.
2, right? So the Laplace transform is 1 over s plus
2.
2, right? So s plus 2. But this one only apply to this. What do we have here? There's 5 in the front. So use a linear property. 5 on the top, right?
Yeah.
Is 5 on the top? Like this? Yes or no?
Yes.
Yes, okay, so that's the first part. Then I do the first part of the second part, right? So minus 3, right? Okay, now your turn to do this thing for t.
So it's 4 over s squared
It is 4 over f squared
plus
plus
0.
plus 0.
Where's the
A here equals 0, so that's why it's gone. This part, right? So
Okay.
omega squared s squared plus
2. It's 4 squared.
4 squared, right? 4 squared. Right? You can write 16 or you can write 4 squared, but same thing. Not 0, not 2, not 4, it is 4 squared. Right? Then we can just combine together, so this one will be 12, right? Like this?
Wait, isn't that last one for,
This one?
wait, isn't that for sine omega t times?
Sine omega t times ut.
Or isn't there supposed to be e times, like times e to the 8?
Huh? What?
Well, I have mine written down, so. You're looking at this.
Yeah, a equals 0. Right? Because this one is 1. E to the 0 equals 1. So a equals 0 here. So that's s just s squared plus omega squared.
Okay.
Omega equals 4.
How come they're using this one?
This one is cosine.
No, this one here.
Yeah, you can use this one. Same thing. Omega or omega squared plus omega squared. I didn't write that one on the top. I just combine these two together. Right? At the beginning, I write this one and this one, but I add this to the front. That one is a special case.
But where's the omega squared in the denominator?
Yeah, this is omega squared and the denominator.
What, like the other one?
This one, here, omega squared. This is omega squared. This one is not cosine, not sine function. Okay, I see your point. At the beginning, I write omega t. This one gives us s squared plus omega squared. You have this one, and you have this one. Then omega t gives us omega s squared plus omega squared. You have these two before these two, right?
Oh, I wrote s squared plus a squared on the denominator.
So this one. Then I said, okay, I can just make this more general. Put this in the front, then this one s must be replaced by s plus a. Combine together, right? Question on this? It's good? Alright, next one. X t equals cosine squared t. Look on the left. Which one we can use? Directly. Do we have anyone? A cosine t squared.
We're squaring the t, so would we use 5 t to the in power? That's something to do with it.
Looks like we don't have that what you imagine is, okay, if xt give us this, then what is x squared give us? It looks like we don't have this formula. You know, we don't have this property. If xt give us xs, how about this square give? We don't know that.
That's just xt times x.
Yeah, just x. Yeah, this is xt times xt times xt. Right? Then what to do this? You need to use this xs convolute with xs. Remember, in time is times, then in frequency you need convolution. You don't want to do this, right? Alright?
Let's say the multiplier in the Laplace.
No, multiply in time domain corresponding to convolution in Laplace domain. Convolution in time domain corresponding to multiplication in Laplace domain. Okay? One is easy, one is difficult. So that's why we want to do this transform analysis. If in one domain is not easy, then you convert into another domain, it's easy. Convolution change into multiplication. Right? So don't use this one because we don't want to try. Right? You can do this, right? Cosine t. What is cosine t? Cosine t is s over s plus 1, s squared plus 1, right?
Just cosine.
Yeah. Cosine t is this, right? Then we said, okay, you use a convolution. Right? I don't know who wants to do this. At least I don't want to do this. Right? Okay, we need to figure out another way. Make this thing something in the table. You need to use what we learned in trigonometry. Use identities. And we mentioned this time who is in 315 and 316.
16.
We used this already a lot of time, right? This is called the demodulation process. Cosine squared. We are going to learn this, then use this in 315. You don't need to worry about this here. But this is in trigonometry. You need to know this in math 103. I don't like this square. Instead, I like this only cosine function. I don't like that square, so you need to reduce the power from 2 to 1. That's the identity is called, right? The double angle something? Still remember this?
Yeah.
Okay. The cosine 2 theta equals what? Equals 1 plus 2 cosine theta squared, like this? Minus, right? Let's see.
You want to look it up for you?
Minus, right? I believe minus. Why? We can see this one is always between 1 and negative 1. So this one will be between 0 and negative 2. Right? So this is square, so this is between 1 and 2. So either plus or minus, so this one must be correct. Right? So we use this identity. Right? Here, cosine squared, cosine squared. Does this remind us something? Right, so this one will equal to half 1 minus cosine 2t. Yes?
Just that identity too.
I believe this one is must be I should ask you to double check, right?
Yeah.
Looks like this one must be plus.
And then you come around.
Right? This one is like this. Right? This thing minus 1. It's called double angle. Cosine of double angle. 2 squared minus 1, right?
Yeah, so. Actually, it's not fun now.
Okay, anyway, we assume this is correct. You double check if it's wrong, just some like science, that's no big deal. But the idea is valid. Alright, suppose that's equal this. Now can you do it? Now keep in mind, we always said this one is greater than t, so there's ut at the end, right? So always consider from 0 to infinity, positive unit. This equals, how many terms do we have here? 2, right? Right, so the Laplace transform also has 2 terms. Right, the first one is half, right? Is this half? Half ut. Which one? Which formula are you going to use? 3. So what's the result? 1 over s, 2s,
So 1/2 S.
1 over 2s, right? 1 over s divided by 2, right? So that's the first part. Right, now the second part, I write the half here first. Right? Now it's your turn. Right? Which formula are you going to use? This one, right? This a equals 0, so just s squared plus omega squared on the bottom, on the top is omega.
Well, wouldn't it be A actually, because it's cosine?
A is nothing, A is 0. Okay, let me write
It's
it.
talking about 8, number 8.
Huh? Number 8 is cosine.
Yeah.
Oh yeah, you're right. Okay, we use cosine, right?
So it would just be your S
S on the top,
over,
S squared on the bottom,
yeah,
plus
2 squared.
plus 2 squared. Okay,
2 squared, I think so.
so don't trick me. Okay, plus 2 squared, plus 4, right? Make sense, everybody? Plus 4. All right, now you simplify this. Right? You can leave it like this, but usually you just combine these 2 terms together. If we combine 2 terms together, this result equals s squared plus 2, and on the bottom this s squared plus 4. And just add these 2 terms together. Any questions on that? Need some time to think? Everything's good, right? Alright, next one. Xt equals t to the e to the t to the 2t. Again, t is greater than 0. This one. Look at the properties on the left. We always do like that. Which one you want to use? These are the pairs. We need to use the properties. We didn't write the properties here, but you still memorize the properties, right? I hope. So what are you going to do this? This t to the et is not here any, so we cannot do that. Right? We need to use properties. The properties means okay, you have a function like this. We can easily calculate this. Then you modify something like this. For example, times t. Then what do we have here?
T
if you multiply by t, means what you do. Right? So that is one way. Or we can use something else. Right? So now, at least we have two methods to do this. Right? Because we can use t as the basis. So let's find t first. Then I use t multiplied by e to the 2t. This one. So that is the first way. Everybody follows what we are doing? Yes or no? First we try to find the Laplace transform for t. Then once we know this, looks like okay, we just multiply by e to the at. If we multiply e to the at in time, then in the Laplace we just replace this s with the s minus a, right? So then we can easily write out the Laplace transform for this. This is good? Okay, can you try? First one, we consider this one is the x, the original signal. Once we find the Laplace transform for this, then we just consider our signal is the original signal multiplied by e to the at. Then we just make some manipulation, then we get the Laplace transform. Okay, so step one, what is the Laplace transform for t?
Would be 1.
1, that is the impulse, not t.
Is it S plus A?
S plus, we don't have s plus a. Which one?
Is it not just S?
1, 2, 3, 4. Which one? T. What is T? T is RT, right? Is RT is T?
We could use number 5.
Number 5.
T is the first power.
Yeah, but RT is T, right?
How's RT T?
Right? Is T the same thing as RT?
Yes.
Because keep in mind, we always T greater than 0. What is RT? RT equals 0 when T is less than 0, the T when T greater than 0. So is this is what we have, right? T greater than 0, so T. This is RT? Yes, right? T is RT. Yeah, okay. So what is the Laplace transform for this?
1 over S squared.
1 over s squared. This one is not what we want. What we want is this one. So how to get the Laplace transform of this from here?
We would just do the transform for e to t, and then we'll talk and get it right.
Now we need to use that property. Okay, suppose we know this. How to get this? E to the at. If we know xt, get this, like here, we already know that. How about this one times e to the at? What is this? The properties. We need, yes, s minus a, right? We need to replace, we use the same form, but we replace the s with the s minus a. Yes or no?
So it would just be 1 over s minus a squared.
Right. Yeah, yes or no? Forget the property last time? So that is true. So this one will be, or I just copy the forms here, s squared, but replace s with s minus 2, right? Minus 8, so minus 2. Okay, that's it. Question?
What property is that again?
The property is if we know xt give us xs, then you multiply by e to the exponential to the original signal, then this one will keep the same form but replace s with s minus a. Right? That is called multiply by exponential, complex exponential. That is a property just on the last slide. So you can see we discussed this last time. You memorize this, or at least know this, right? Question on that? Alright, that is the first method. Look like this question is very good. Okay, so we are going to try another. Looks like this one, I can think this signal is this one times t. We have a property that if we know xt, we get xs, then times t, xt. What is this? Times t in time. What is it? Times t in time? Differentiation in frequency, right? Right? So I will go into differentiation of this one. Again, this property is the property before this one to this. And this one is the easiest one because you only multiply by t. How about if you multiply by t squared? You do the second order differentiation, then you multiply by -1 to the 2, and 3 and to the 3, 4 to the 4. Any questions on this? Right. So in this case we have n here. So that's this is 1, and this is 1, this is 1. So this is the result. We are going to use this property to try again. E to the 2t give us what? Your turn. Everybody follow the procedure we are going to do, right? Yes or no? Yes, okay, so now we do this first. Then once we get to the Laplace transform, we use this multiply by t property. Then we get. So what is e to the 2t? Keep in mind, we always have this one. So it's ut. 1 over
2 plus 8.
that is this one, right?
Yeah.
1 over s
Plus 2, yeah.
S minus 2.
minus 2 or plus 2?
Minus 2.
Minus 2. Plus 2. Which one?
It's minus 2.
Minus 2, right?
Yeah.
Minus a plus a. Plus 2
Minus 2.
minus 2. So that one gives us 1 over s minus 2. Question on that? No? Okay, so next one, we finish this part, right? The next one is we just multiply the t in time. That means we take differentiation in Laplace domain. Then multiply the -1. Good? Right? I ask somebody else, can you do that? Then what is t e to the 2t? What is this? We multiply by t in time means we take a differentiation in Laplace. Right? So d ds, this is only t to the power of 1, so there's only first order differentiation. And 1 over s minus 2. Yeah? And on the front, there's a negative 1 to the power of 1. So which means negative. Okay? Right? Now we need to evaluate this. What is d ds of this one? X over y, what is the differentiation for this? Something over something differentiation, what is it? This one will be equals to y squared, okay? This differentiation times this minus this times this one differentiation. Okay? That is, what is this? Differentiation of fractions or something, right? Okay, so here, that one will be equals, okay, don't forget this s. Okay? And on the bottom, this s minus 2 squared, okay? Because y squared. And this one here will be the differentiation of the 1 times this minus 1 times differentiation from this. Okay? So this differentiation of this one, differentiation of 1 equals what? 0, right? Okay? So that's top on the 0. Then minus this one, 1 times differentiation of f minus 2. Differentiation of f minus 2 equals what? With respect to f. Equals what? Equals what? Yeah? No? No? Who took 168? The prerequisite for this is 168. This one is in 167. Differentiation of something. Differentiation of x minus 2 over dx. What is this? What is dx over x? Dx. Okay? What is dx minus 2? What is d2 dx? This one equals what? 2 does not change with respect to x. It's always constant. This one, x minus 2, the same thing as this one. So equals 1, right? So this one will be equals 1 here. Now, this is 0. We don't need that. Negative 1 here. Negative 1 here. So that's positive. On top of 1 times 1, that equals 1. Same thing. So you can use both methods to get the same result. Any questions on this? We do not want to use the definition to do this because that's not easy. So we need to use practice with all the pairs and the properties. That's the only way to do this easier, except some special cases. Any question on this? Need some time to think this? Good? Everybody good with this? Alright, now the next one. The next one is xt equals t squared sine at. Again, t is represented. How are you going to do this? Tell me your ideas.
Start with t squared.
Alright?
Do sine of at separately.
We do first the easier one, then we use the properties, right? That is the idea.
Yeah.
So which function is the easier one? And we need to consider also the property. That means we need to have that property. If we don't have that property, then you cannot do that, right?
I'd say the easier one would be sine.
Okay, the easier one is we do this sine first. Eh? The property is, once we know this, then we just multiply t squared. Multiply by t squared in time means take the differentiation in Laplace, right? Right? So that looks like this is workable. Right? Sine at equals what? Right? Now it's your turn. So the bottom is always like that, right? Right? What is on the bottom?
S squared
S squared plus
A squared.
a squared. What is on the top?
A.
A. Okay, we already have S, so we don't have S, so that is A. Alright, that is good. That is this one. Everybody agree with this? Yeah? Okay, now let's do this t sine t squared sine at. How to deal with this one? What property? Multiply by t squared means
It's the same word.
take the second order differentiation with respect to s of the Laplace transform. Then multiply by -1 to the power of 2, which is 1, right? So this one will be equal to -1 to the 2 times d squared df squared, and this part is a s squared plus a squared. This. Right? So this one will be equal to this one, -1 to the square equals 1. So we just ignore this. Right? And we are going to do this. How to do the second order differentiation? We need to do one by one, right? Right? So we do this, and d ds and s squared plus a squared and a. We do this first, then we do this second. Right? Now this one will be equals d ds. Right, what is this one? Right, I will put some. What is this? Your turn. Oh, I just erased this formula. First one, easier, is on the bottom. What is on the bottom? This thing squared, right? So s squared plus a squared, then squared. On the top, it will be this differentiation times this minus this one times the differentiation of this. Right? We do differentiation first, multiply with this, then minus this one times differentiation of this. Right? First one, what's the differentiation for A? 1, 0. Which one?
0. 0 is constant.
A is constant here, right? The differentiation is with respect to S.
So 0.
So 0, right? So on the top equals 0, 0 times this, so we just write 0. Right? 0 times something, so just 0. Okay, minus this one times differentiation of this. What is it? 2s, right? So 2 I will write it on the front because this is constant, and 2s like this. Is this good? Right? So then it's like this. Right? I just remove this s as 0. I don't like that. Make sense? Or we even don't like this negative 2a because it's constant. Right? So can I move this one to the front? Negative 2a. Right? Equals negative 2a times this. This good? Because we need to take the differentiation of this one again, so we want this one as simple as possible. Right? All these things just constant move outside. Is it good? We need to keep going, right? Right? Equals negative 2a. Right? Now, your turn. What's next? Take the further differentiation of this one. Okay, this good news is this is again first order. What is this? I move this one a little bit down. So I need more space. Can you? What's this? Take the differentiation of this with respect to f. Again, with this property. The first way is what's on the bottom? The bottom square, right? Right? The bottom square, so that will be s squared plus a squared to the fourth. To the fourth. Now on the top, that will be a differentiation of this times this minus this one times differentiation of this. So the first one is derivative of s equals that's your favorite. 1. Okay, good. This is 1, right? Then times this one. So I just write s squared plus a squared then squared. This good? Right? S derivative equals 1, then times this. What's next sign? Minus, right? Minus what? Minus this one times derivative of this part. So minus s times the derivative of the bottom. Can you? What is the derivative of the bottom? Your turn.
That U substitution.
Right? That is just the s squared plus a squared squared. What's the differentiation of this with respect to s? Wait. Can you try? 1?
Possible.
It's good try. It's a bold try. It's not correct, right?
Rest to the third.
Raise this to the third.
I think UB is 2A.
Okay, yes.
Two.
Right? That will be 2. This thing, right?
You have to turn that into U, don't you? The U substitution.
Yeah, you consider this one as u, yes.
Yeah.
So that will be 2u,
Yeah.
right? 2u, I just copy this here, right? 2u, then du ds, which is 2s again. Everybody need to be like this. You need to like this. If you don't like, now you will. Good? What is the math? 167. 2 times this thing, then times the differentiation of s squared, which is 2s. Right? So that will be s here minus, don't forget this, right? Minus s then times all this. So that will be times 4s, right? So that will be 4s squared. Yeah? Right, then this one. S squared plus a squared. Oh, looks like that's very long, right? Okay, now we can simplify, yes.
I don't know about the differentiation of the s squared plus a squared.
This one?
Yeah, so in my head, I thought just like the binomial multiplication, but since the only term that isn't going to have a is s squared.
Okay, let me put as your idea. So this one here, what we do is you consider this part as a u squared. This one, right? I make this part equals u. Change a variable no matter what. Right? So this one is just u squared ds, right? And this one will be equals to d u squared du, then times du ds. Right? And this one will be du squared du, so that's equals to 2u. U squared du equals 2u, right? Then du ds, u equals this one. So du ds means 2s. Then we don't like u, right? Because we don't have u. U is an intermediate variable. So we replace u with original s squared plus a squared, then times 2s. That is what you suggested. Use this called change of variables. Make sense? Good? Alright, we just after class read some review the differentiation rules. Right? Okay, that's it. But we are going to simplify this. Right? So in the test, you don't give me this. We like to make this one as simple as possible. Okay, so I will. Can you read some part? I use this part. I use this also. I use this also. S squared plus e squared on the bottom, that's 4. This one is squared. This is only 1. So I at least can cancel 1, right? So that will be equal to negative 2a. On the top, that will be s squared plus a squared. This 2 will be gone, right? Cancelled with this. And on the bottom, this one minus s 4s squared. This one is be gone. And on the bottom, that will be s squared plus a squared, then to the power of 3. Yes? Now, this is 4s, this is s, so this one will be, this one, we don't need this. And this one will be minus 3, and this one like this. Then looks like this one is good enough, right? So you can just leave it like this. Any questions on this? Any questions on this? Good? All right, let's do another one. This one's easy. Okay, I'll let you do it. This one. Everybody try this. Get it? Anyone get it? Okay.
Okay, 1 over S minus 3.
1 over s plus 3
Yeah.
square plus 1. Easy, right?
That's not what I got.
Huh? No, what do you get?
Add it all.
Huh?
I just got 1 over S minus 3 times 1 over S squared plus 1 squared.
1 over s plus 3 times. Let me see what you have.
I mean, I guess I need to draw.
Okay. Sin t is this, right? Okay. Yeah, sin t is this one, right? You get this correct.
Yeah.
Right? Then you multiply by exponential. You need to replace this s with s plus a. That is it. Right? So,
Oh, yeah, you're
right?
right. See,
So
that's-
this one here, you only consider this part that is 1 s squared plus 1, like this. This is only for sin t.
Yeah.
Right? And time this one, you just replace this s with s plus 3. That's all.
Gotcha.
Right? You multiply by this s is something like take the differentiation. Okay, any questions? I need to give you some quiz. Right? Let's do it. You need to be able to do this. The homework is practicing this. The second midterm is almost here, right? Right? You need to do this also. And in 412, if you are EET, then you need to be able to do this also. Right? So don't think you can skip this. Everybody get a piece of paper, right? Then write your name and the ID, then submit. There's always UT for each signal, huh? So I just ignore that part. I mean, I want to write this. Let's try this 4 first.
Yeah, same.
You only need a piece of paper and your pencil on the table, right? We can discuss, we can ask, eh? Quiz. Get a piece of paper and a pencil, do it. Yeah, you can discuss. You can ask. Eh? If you know this, tell others. If you don't know, ask others.
Who don't know more?
That's much. Which one? What is that? Usually what? Which one? No. What's on the left side? Next team.
G9 Thomas?
Yeah. What? What do you do? Like smear. Is that 14? What is it? Is that a 14?
Read.
4. Is it a what? Princess. Oh. Where's the closing? 3D, before the YouTube? What? Is it a negative CC? Yeah. Okay. Like I need glasses. No, it's never helped.
Number 2 is that 14E.
This one?
No.
Parenthesis. And 4e to negative 2t. This one is again, yes. This one is again here and here. If anyone finished one, let me know. Let me happy a little bit.
T is greater than 0.
Yeah, so just ut, everything is t greater than 0. Yes, everyone has ut. All these have ut here. Right, so that's one-sided Laplace transform.
So 7e is this 13? What is that? Minus 13. Minus 13.
Or a B, yeah, that's
Okay, we get somebody first one correct, huh?
I fight face. Please change
This is almost good, right?
Three.
There's while, so definitely multiply by 5 is good. Means you replace this f with f
X plus 2.
Instead, you change this A.
So
What you do is I
when the negative t,
That's what you do.
since earlier you said t, so we got to do the same changes.
That is
Minus.
everything else on the bottom. Originally,
What about just the two?
This F is no longer F.
Because that turned to S.
One right is not.
Don't move.
Yeah, okay. So we have a second one is correct, alright? Discuss, discuss incorrect.
So from 3.
Yeah, just separate 2, 4, F plus 2, 3, F minus 3, yeah.
Okay, so 3. I understand what happens for the 2 e to the t and the minus t. What happens to what happens to the 2?
2 is constant one, is 1.
Yeah, so it would just
That
turn
is
to
ut. That is 1 is constant, that's ut. Number 3.
So you're telling me it would be 1 over 2? Or you're telling me it would just be,
That is 2, right? Minus 2.
Yeah.
So that is like minus 2 ut.
so once you figure out that 2, it would be negative 2 over s.
Negative 2 over F.
Well, this is
That's the problem. This one.
I gotta figure out how you get this with the, like,
Two is constant, that is ut. This 2, that is ut. And because 2 is constant. What is ut? Ut is like sum from K or all these two, like ut is 1. This is minus 2 ut.
Square.
keep going, you stop when you
Oh, yeah, that's right. That's right.
And this T is that's this one, this 2 is 2 ut.
Oh, okay. So 2 over F.
3
3 over F.
minus 3.
4 over S minus 3 plus 3.
Okay, nice. Okay, good. Okay, good. Okay, good. Okay, nice.
Do we have to simplify from that form?
You don't need to, except somebody says you need to do that. Otherwise, this one is very clear.
I'm not doing Are these good?
Third one. Third one is. Third one. The third one, how to deal with minus 2.
That's just. Oh, wait.
2 is a tandem signal. That means, for example, 1, this is ut. That is not 0, that is ut. Right? Ut. Oh, okay, so here you go. You did this part here, right? That is omega, right? And squared plus 9, that is good. And then 5 here, so you put 5 on the front, that's good. Now you multiply by this one. You don't do this, don't multiply by this one. Okay. What you do is you change this S into a F plus 2.
So all of these are multiplied
It is not multiplied by 1.
by S plus 1.
It is a change this S with S plus 2. Okay. So that means this one will be 5 times 5, 3, and this one S is no longer S, it's S plus 2.
That's delta t times ut,
Then you this one.
which would be RT.
Keep in mind, you multiply by ET, e to the AT in time. You multiply by ET in time. That means you keep this same thing here, right? But you change this F into F.
I think it is.
So which case it's going to be?
5 over S plus 2 is 5 over S plus 2 squared.
Write that one down first.
The first part, no, the first part, this one is no longer be here. You just, okay, consider this part. This one is this, right? You consider this part X, this one is just XS. Then you multiply by E to the AT. Very simple. You just replace the F inside here with F minus A. You don't multiply by something. So for sin 3t, that is this one, right? Then you multiply E to the negative 2t. You just replace this F with the F plus 2. Don't multiply by this. You replace this F with F plus 2. That is the problem. And the 5.
Got it.
Right?
And then would be 2 ut.
Talking about the delta t.
We have a set of
Why would it turn into 2?
Because
Wait, let's put together.
it's just delta t up there is 1.
Is clear the first one? Yeah. Okay. If you know
But it's
that
actually delta t times
you want
ut.
to explain.
So is it 1?
Would it be?
Okay, so the first one is you do this first.
2 delta t.
Then 3t. What's the Laplace transform for this? That is f squared plus 9 on 3.
Because it's
You forget this square. Alright? Yeah, this is good. And times 5, okay, you multiply by 5 in front, that is good. This is good. But you multiply by this. Also, this one.
It's all done.
This one, you shouldn't do it.
This is weird.
So you will do this. And this one is not. Alright? It's much easier than what you do this. You just change this f
4.
with the f plus 2.
No, 1 over. So 2 over s squared. Because I think it's.
Right? You change this f with the f plus 2. You don't multiply. You don't multiply by this part. You don't multiply by this part. You change this f with f plus 2.
Yeah.
Yeah, the square is always here. Basically, every f.
So
This one? This one is wrong. Yeah, this one, but you need to change this f with the f plus 2. Alright? That make sense?
It's got it.
Alright?
Or cook, yeah. It's got it. Right
This one.
Do you remember when we were doing the other stuff?
This one.
Well, I wasn't even here, but he talked about it one time. Where is from this? Remember we had like UT times like.
This one here, and one. This T is good.
We do that today.
Now, what is this one? One is good.
One time we were doing like the first one.
Yeah, new T, look at the first one. No, that's not right.
Oh,
It is constantly in time, but it's not constantly in frequency value. That's why
What is
B? Yeah, you combine.
That's delta T.
Next. Later time you develop. Right?
No.
I'm pretty sure. Okay, so now
Two delta T.
this one is
It's got to be one plus
this
two.
one is this one is not constant in time. This one is like all
In that case, it would just be.
Everything else is where you
You don't tell me this is A. You didn't tell me what A is. What is
It's
A?
just, it's
Negative.
it's gotta be
Right?
just
This
two.
one must
I think it's just two.
be
No, it can't be, because the T's are up there.
Yeah, it is.
See, no, it's not.
Wait, what?
The delta T up there.
Yeah.
There's no T.
It's one.
There's no T up there.
Correct.
It's just the Laplace transform.
Delta T, yeah. Correct. It equals one.
See what I'm saying?
So delta T.
No, it doesn't.
One times two.
You can't just do that.
You can.
No, you can't.
So for this one, would you do the same?
This one is you have this term and this term.
You can't just
So you just do
multiply.
one by one.
You have to
So
do
the first term is 4 e to the negative 2t, right? What is this? This one is 4
You have to
e to
convolute
the
it
2
in the Laplace
negative
domain.
t.
We don't convolute anymore.
Okay,
That's
so- So
the
then what is one convolute?
You want to square that, you want to
This is
replace.
what?
You don't replace because this
Gotta
one
be.
is you don't replace this one because
It's gotta be
this
two.
means you multiply this with some signal.
It's either
You
two
replace
or
some key. So that's
weird-
not
2 over S.
So if it's
No.
like something like honors you replace, but this one is not. Yeah. And you do the second part of almost the same. Just Oh, yeah.
would you add them together?
Yeah, because you have two terms here, then you have two terms there. That's a linear problem, right?
It's a quick one. 2. Alright.
First one.
It's 1.
Yeah.
2 times 1. 2.
Yeah.
Where'd you be?
Wait,
Just
so-
2?
So I was thinking,
Okay.
that's delta T, but there's also a UT.
No, delta t. Delta t is delta t. Delta t times ut is still delta t.
So that'd be the answer.
This is good. This is good. This is good.
Okay.
That last one. Wait.
Good. This is good.
Oh my God.
Because it's
You put UT in there. Look at the stuff in the parentheses multiplied by UT.
That's where I have it. Just 2 sides.
I'm right there. If you just, if you get to the you like, says
Everything good? Okay. Anybody still need help? Huh?
Nope.
Everybody need to perfect, huh? You know this, right? What's the other? 2 over plus 1 or minus 1? But this is negative. Positive is negative, okay? Then this is going to be okay, 1 over x squared.
put like
This
weird.
one is 2 is constant, that means minus 2 is u. Equals what? 1 over x. Right? Good?
That drove the
Everybody is good?
We're broke. So it's positive. I don't ever use cruise control anyways.
It's 12 hours, right?
Yes.
Yeah, it's good. Same as last one, I guess. Yeah, that's standard. Check.
That's not how that works.
I don't need this. Everybody press correct. And if you saw in the other
Cruise still works the same.
Great. Hold on.
No,
I just take them out.
yeah, impulse is one. You have two impulse, then you have two.
I can barely read.
Then.
I can barely read.
Say E to the.
My knees hurt.
I thought about it. I might still get it.
Everybody sign this, all right?
You got his girl?
I got